Okay, well, let's just roll it. Who knows?
All right, go ahead.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 295, a circuit graver, zinc creep, and video tubes. And welcome back after our week off at Supercon. It was really fun to see y'all. Thanks very much for your positive feedback on the podcast. And it was really cool to see 3 or 4 people out there with Hackaday podcast t-shirts. We were trying to think about how many of them there are in existence. And the number's probably around like 100. So to see 3 or 4 of them at Supercon was pretty impressive. This week in Hackaday news, I just got back from Supercon. Had to do Hackaday payroll, had to zoom down to San Diego, visit a friend of mine for a day, and then fly back out here to Germany, where I arrived about 2.5 hours ago. And boy, are my wings tired.
Jet lag always makes for the best podcast experience.
Yeah, so if I sound like I'm operating on no hours of sleep and a bucket of crazy pills, well, you know what's going on. Anyway, short story long, Supercon was absolutely fantastic. It was great to see everybody. You always come back from these just full of crazy new ideas, and this time was no exception. So that's really fun. Also, a bunch of new story ideas. Yeah, always a super productive time.
Yeah, it looked like it was a good time.
What else in the news? You've got space news?
Yeah, I wrote up a story last week about how Voyager 1 went into this weird fault state that seemed to be triggered when it was kind of a, what does this button do moment. They turned on a heater. At some part of the equipment needed a little bit of extra heat, so they turned one on, and so 2 days later, when the acknowledgement finally came in, they realized that it hadn't actually flipped the switch. The acknowledgement was missing. That led them to kind of search around the bands and try to figure out where Voyager was, and they managed to find an S-band signal, which sort of gave them kind of this cascade of events that, they turned the heater on, it went into a fault state, and then had to shut down a number of different systems, including the main X-band transmitter, so it fell back to the S-band transmitter, which hasn't been used since 1981. And it worked. It came on and it worked. And I don't know what the story is now. I don't know if they've managed to get past the heater fault and then get back to X-band at this point. But at the last I heard of the story, they were still in communication with Voyager and trying to figure it out. So here's hoping that it'll come back to full service with its 4 instruments and its rapidly diminishing supply of power from the RTGs. But, happens to the best of us.
I love the Voyager, the continuing saga. It's full of roller coasters. Like, this is insane. They try to turn something on, it doesn't work. It cuts the radio out. They have to use some old crazy radio. Like, it's just pure remote control hacking, but it's remote control hacking with this, like you pointed out, 2-day delay in the middle of it.
Yeah, someone in the comments on this article had to be snarky about, well, why are we spending all this tax money on this, blah, blah, blah. Someone did a very interesting analysis of exactly how much resource from JPL and NASA is being put into Voyager, worked the numbers, making some assumptions and everything, and it came out to some ridiculously small percentage of NASA's budget, 0.001% or something like that. I forget what the exact number was. And that was assuming people are working full-time on the project, like 18 people working full-time, which is certainly not the case. It's not like, 18 people stand around while one guy pushes a button to send a command, and then they wait 46 hours for I'm still on the clock. No, we got to wait for that command. It might come back anytime soon. No, it's not like that. I mean, obviously they're doing other things. They're being more productive than just servicing Voyager. So it was a good sort of, hey, come on, reality check here.
I mean, it's got to be amazing value for money. First of all, how many other anythings do we have that far out? Nothing. None. Zero.
Nothing.
So like the marginal value of a little bit of science at the absolute edge of the solar system has to be something. Yeah, so first of all, and B, it's on such a string budget anyway. It's such a small crew running it, et cetera, et cetera. Incredibly low cost, at least in the sense that it's the only one we've got out there. So like I can't even imagine asking that question.
Yeah, and the only opportunity cost that I see is the fact that it's plugging up the deep space network for a certain amount of time. It's a very low bit rate at this point, so the messages take an awful long time to send and receive. While the message is in flight, there's plenty other things that DSN can do. So I don't think that's really a problem. Let's just keep Voyager going as long as it wants to keep going at this point.
Well, would you like to head on off to What's That Sound?
Sure will.
This is a journey into sound.
What's that sound?
What's that sound?
In honor of Supercon, brought you a sound back from Supercon itself.
Okay, let's see. Or let's hear. It just sounds exactly like.
Is that one of the ones with the...
No, it's the one with the.
I'm sorry, this is the one with the...
Oh, I couldn't tell the difference between the and the. My God.
I tell you what, how much of a stickler can we be on this one? I mean, it's obviously a... If I told people that this was an entry into the badge hacking challenge and was actually an SAO around someone's neck, would that help them or confuse them further?
I think that would confuse them further.
Be as specific as you can. We'll see how the answers come in. We'll figure it out then. So head on over to hackaday.com/podcast. Handle your best guess and your email in case we pick you next week to get a Hackaday podcast t-shirt. Well, my first hack this week also comes from Supercon. This is Zach Frieden's circuit graver, and this is an awesome PCB making device that he actually gave a talk on in the design lab. We'll have to process that video and get it up for you real soon. Until then, you can go check out his Hackaday.io page that we linked in our write-up here. It's an interesting take on the kind of PCB mill. Instead of using a spinny, loud, and horrible toxic dust making spinny mill blade, he instead uses a cutting tool from a lathe. And so this is one of those really sharp carbide cutting tools, and builds a really fantastic 3D printed machine around this thing so that it can carve out isolation on a small piece of PCB. What's really fun about this is that it needs to be a 4-axis machine. So it needs to go XYZ as you'd expect, but because this lathe cutting tool has a front side, and actually he needs to get the rake angle on it just right to have it pull up nice clean cuts out of the circuit board, there's actually a 4th angle where it needs to be able to spin around so that it aligns the blade with the cuts. But what's really cool about this is just how impressively fine separations and fine pitch he's able to get out of this. Zach claims that he can get 8/8 design rules, that's 0.2 millimeter trace and space, very well. And if he moves down to 6/6, it's a little bit sketchier. What's fun about that is that's kind of bordering up on what you'd use to get a professional PCB made anyway. And so this means that your PCB prototyping stage can use the same Gerbers as your send it off and get it manufactured one. That is, if they're kind of weird. Because what's really fun about this, he's cutting out isolation traces. While you could make kind of arbitrarily complicated paths, he's actually doing some really neat, very artistic looking stuff with, slower curves and bigger chunks of copper under the LEDs. I was watching it run live, and he showed me a bunch of the boards he made, and it just makes fantastic looking boards. Unfortunately, in his Hackaday.io page, he doesn't have the SAO he made for Supercon, but it's got the Supercon 8 logo in it and a bunch of, I think, 0402 LEDs soldered to the board. As a person who occasionally makes PCBs by just taking an X-Acto knife and cutting out isolation traces like this, I definitely appreciate the ability to make boards this way. Doing it precisely and with this custom mill machine is really pretty fun.
Yeah, I really like the design of this. It's so much cleaner looking than having that V bit spinning around and kicking up the copper shavings and FR4 dust from the substrate. And I mean, that's still all there. You're still creating that swarf, but it's more controlled, I guess, is the way I'm looking at it. And way neater and way quieter. I mean, this thing's just zipping along and raising its, curly little bits of copper and just kind of going about its business. Nice idea. I mean, I've seen a lot of graving, the manual kind. I mean, the stuff that Uri Tuckman does, and then there's the stuff that Clickspring has been doing, decorating some of his stuff. But that's all decorative stuff. It doesn't have any function, and this is an interesting functional use for something that was, pretty much designed to be a decorative, an art form sort of thing.
And you do have to check out the machine. It is almost all 3D printed. It's on linear rails up and down, and I think there's an aluminum piece on the Z-axis. Well, there's a little piece of aluminum on the Z-axis, but what gives it stability and the ability to travel up and down is actually a really super chonky 3D printed flexure. And it's kind of fun that this is able to move up and down, but not get pushed backwards and forwards by the force of the graving bit as it's going across this thing. In practice, it's, probably 2 inches wide. It's it's a big old 3D printed part. But what's really cool about this frame is that it is basically entirely 3D printed and uses flexures here and there and a couple other, like the lead screw is actually on a part that's got a little bit of play in it due to the way the 3D print is designed. There's just some really very clever 3D print design here in making this thing. I mean, it's a 4-axis machine and it's got such beautiful, crazy coordinated movements. I really, really like that part a lot. Yeah, it's just super fun to watch it go in real life. It moves surprisingly fast. The other thing he did that was really fun for SuperCon is he got custom blanks made all the same size. So they're all the same form factor, and he got them Enig coated. So he actually just ordered PCBs where they're all just nothing on them. No solder mask, no nothing. Just ordered PCBs in a certain size and was using those as blanks. It's absolutely horrendous abuse of cheap PCB services these days. They're nice and flat. They're all dimensionally basically perfect. Like, it's hard to beat that. So that goes a long way towards solving some of those problems with the flatness. He also has the 3D printed base for it also has nice little dovetails and a wedge that squeeze the little pieces in there fairly stably, presumably without buckling them as well. So incredibly nice machine design all around and a really satisfying machine to watch run. He manages to take it all apart, put it in a Pelican case, and bring it to a conference where he was cutting out tiny little parts. So it's early days with this machine, but I want to see a few more of them remade by some other people, and everybody can get working on it.
All right, first up for me, Zinc Creep and Electroplasticity, Why Arecibo Collapsed. This is a report from the National Academies who put together a committee to look into the root causes of the Arecibo radio telescope, which collapsed in, I think, December of 2020. I mean, we've probably all by now seen the video of that, and it was kind of one of the most telegraphed structural failures in engineering history, I think. Unlike a bridge collapse or a building collapse or something like that, they knew this was coming. They were able to collect a lot of data on it. They knew there was nothing they were going to do about it. And there really was no mystery about what the failure mode was. And if you haven't been keeping score at home, what basically happened was one of the cables, or a number of the cables, on one of the support towers that holds these huge cables up over the natural valley that the primary reflector was in, and held this 900-ton platform where all the scientific instruments were. A number of those cables started suffering from pullout of the sockets that held the steel rope, the wire rope, into the support structure. And the part is called a spelter socket. These are things that are used in rigging all over the world for hundreds of years now. And basically what it is they take the cable, the steel cable, and they put it inside a cup, and then they splay out the individual wires of the cable, fill the cup with zinc, molten zinc. When the zinc hardens, it bonds to the wires individually and then makes it so that it can't pull out of the socket. That socket can then sit in a saddle you can proof how strong these things are, and the hundreds and hundreds of tons of force. And they're used all over the place, and there's dozens, I guess, in Arecibo. So why did one fail? How come this was the one and only spelter socket that has failed in this way in 100 years of using them? What was different about Arecibo? And when they started asking that question, then it became obvious what's different about Arecibo versus all the other places where spelter sockets are used. Nobody else had a gigantic radar transmitter bathing these cables in RF energy for decades. That becomes an obvious thing that you want to check out. They weren't actually able to do the work to prove that that's what it was, but they make a pretty good case for the red flags should be waving, and this is something we should be checking out based on the fact that nothing else fits the failure mode. All the other explanations, like hurricane, I can't remember the name of the hurricane that came through like 39 months before, did cause some damage and probably started the collapse process, but the pullout problem was already a known phenomenon at that point, and there was no reason for the zinc to be doing this. So their hypothesis at this point is electroplasticity, which is a known but not well characterized phenomenon that with a certain amount of current through dissimilar metals, you can actually cause one of the metals to soften versus what it would be if it weren't subjected to these electrical currents. So the thought is that all of this RF energy is getting coupled into the cable through skin effect, being transmitted up or conducted up into the zinc sockets, where it was having this electroplastic effect on the zinc enough to soften it. And it's not really softening, it's more of it's not really related to a phase change. I don't really understand it fully myself. It's kind of some hand waving there what electroplasticity is, but it basically, at the end of the day, it softens the zinc to the point where it was able to pull back away from the individual fibers inside the socket. And then we saw what happened on December 1st or whatever it was of 2020. Not conclusive, but certainly suggestive. The whole report was really interesting to read. It's like 98 pages, and it goes into a lot of detail and a lot of different ways to look at the data that they already had, and then kind of suggest paths forward for looking at other failure modes that might be similar, these small currents. And it doesn't have to be RF. It could be currents from from dissimilar metals, from like anodic kind of corrosion or cathodic corrosion, I guess it would be. And, other kinds of these microcurrents that could be causing electroplasticity in some kind of situation that's similar to this.
My next hack is a super sweet little robot hack from Eric Yufeng Wu. Little Quadruped has PCB spine and no wiring. And there's both a GitHub for all of the parts you need here, but also an assembly video, which is just, first of all, beautifully made. And second, you should have a look at it because it's got a lot of Eric's secret tricks for this in designing and building this robot laid bare. So if you want to rebuild it, the GitHub's the way to go. If you want to watch and learn, definitely check out the video. The thing that's most striking about the design of this robot is that it basically has no wiring at all. It's a quadruped, and it's got 8 motors. And you would think that would mean that all of these servo motors have, 3 wires, 4 wires, all going back to the PCB. But no. Eric has designed this so that the motors can screw directly into the PCB. And that's one of the first coolest things about this design, is that he actually takes the motor apart. It's got like a little faceplate on it. Removing this faceplate exposes the pins that would otherwise go to wires to remotely hook them up. He designs the PCB with a little cutout for these and a little 3D printed spacer, so that once you take the face off the motor, it can actually screw directly into the PCB itself. And so you've got a really strong mechanical connection, but it also plugs itself straight into the PCB. And that's really, really sweet here. It means that there's not much going on other than batteries, PCB, motors, which I guess in a way is all you need for a robot, sort of. The legs are of the kind of 4-bar linkage style, or is it a 5-bar linkage? I don't know. I'm not a mechanical engineer. The legs are built like, actually kind of like two legs connected together at the foot, and each one of them is driven by one motor. It's like those, I guess we've seen them in drawbots that use this same linkage to move pencils around and stuff. It's a fantastic way to get 2 degrees of freedom from 2 motors, as long as you don't need the full like XY square range of them, which you don't with legs here. This is a fun robot to watch in motion because it's got a fun range of gaits, and it looks like it's not incredibly expensive to build either. I think basically the cost is buying 8 of the moderately fancy Dynamixel servos that he uses, which are servos that have the controllers built into them, so you can drive them in a constant velocity mode, which is, I think, key here. Anyway, watch the assembly video. It's a fantastic, sweet little build, and it'll give you ideas if you need to make something compact and lightweight like this yourself.
Yeah, I just love that direct to the PCB mounting of those motors. That's really, really slick. There's nothing wasted here. No, no wasted space, no wasted wire, nothing unnecessary. This is like high level design, it's very impressive. And those servos themselves with the controllers built in there, I think they were the key to this kind of, if you see that, you can disassemble them to the point that he did but not going too far. And then it also offers that, those pins for you to connect to the PCB. That's really slick. I think that was probably the enabling part here.
Oh, and Dustbuster 7000 also calls out that he has a neat manufacturing trick. When he's doing the solder stencil, he actually uses this neat jig that raises and lowers a suction section around it that holds the solder stencil flat using a vacuum cleaner. And so he can put the PCB in place, lower this down, it holds the stencil dead flat against it, he scrapes the solder off, and then he pulls it out and it lifts itself directly straight up off of the PCB. So there's none of that tendency. I don't know if you've done solder stencils yourself. It's always the peeling it up phase is always a little bit sketchy. You don't want to wiggle it and smudge it or any of that. This holds it down dead flat and lifts it up directly straight up through the help of this like jig. And it's apparently another open source project of its own, Max Scheffler's Stencil Fix. And I'll throw the links to that in the GitHub for you if you are interested in that. Again, an awesome assembly video of a very slick designed robot, and you'll learn something from that, or even just from the really cool tools he uses to get the soldering done.
And I'm actually going to talk about Max Scheffler's solder station in a second, but first...
No, you aren't.
Yes, I am.
Oh, that's too funny.
So, hardware in the loop continuous integration. This is from Denking, and this is kind of the hardware version of integration testing, unit testing in software development. And if you're not familiar, the proper way, the accepted way, the controversial in some circles way of writing software is to write a test to test a function that doesn't exist yet, make sure that test actually returns the values that you want it to do, and then write the function that solves the problem of passing the test. This is kind of that concept for hardware. When you make a change to software, the unit tests should tell you if you've done anything wrong, because you're expecting it's going to give you XYZ for a value out, and it gives you YYZ for a value out. Thank you, Rush fans. You did something wrong with the function that you wrote. You put some code in that messed it up, something like that. The hardware version of that is, well, I've made changes to the firmware of this system. Is it still going to give me the same results? Is it still going to light the same LEDs? Is it still going to respond the same way to the button presses, things like that? Unless you actually are testing for that, you don't know what your firmware state is going to be. The idea here is to make that automatic. Every time that there's a git push, this will download the firmware, load the firmware onto the chip under test. The microcontroller here, I believe, was all CH552s, if I'm not mistaken. it would load the firmware and then simulate the various button pushes and that the firmware was expecting, and then the appropriate responses in this case was mostly lighting up LEDs. Now it's not actually doing anything like vision analysis to see if LEDs are lighting up. It's just looking at voltage levels. So if it knows that pin GPIO 15 is supposed to go high, and that will light up an LED in the finished project, then all you have to do is look for the voltage on the pin at the proper time. So it's simulating those blinky lights and all that at that level, not actually looking at the results. If I could see that being necessary at some point for some projects where you actually would want to see, that the LED is flashing or an LCD is, displaying the right values, or you even point out, like, if you're doing something like something that has a speaker and you need to, figure out if it's making the right sounds. That might be a little bit difficult to analyze with just an analog to digital converter and taking a voltage level and kind of looking at it with a Raspberry Pi. That's probably asking a little much. You might have to go, into some other different kind of testing regime. But for simple tests, for a microcontroller that's supposed to just respond to button pushes and flash LEDs, this kind of thing can really streamline the automated testing process.
There's so many possible ways to expand this testing jig to support all the possible use cases you might exactly have with yours. Like here, it's just doing, does the firmware do on the MCU what it's supposed to? But you could worry about, are all of the different peripherals you could attach to it behaving correctly? And that would be a much more interesting and involved test rig. But what I really loved is that a whole bunch of people said they're doing this in practice. From CAD The Mad, who used to work at Microchip, where they had a testing rig like this. Chris Gamble comes in and says Mike Stitch, old editor-in-chief Mike Stitch, has been doing hardware in the loop testing stuff with their framework. It's just interesting to see all of the different people doing this sort of thing in industry, and I guess I like to see it happen in hacker practice too. So if you're tempted to dip your toes into hardware in the loop testing, maybe you should. Although the big caveat here, and this comes from CAD The Mad, and I can totally imagine it, quote, "Fun thing is how lousy the coverage on this was and how many years it took to get new MCUs added to the system." And it's true, like, this is a bigger project probably than the project you're testing to make the test rig and make sure that it covers all of the different possible failure modes. So I could see that too, but definitely give you a little assurance that at least the obvious things aren't going wrong when you write that new firmware.
Well, and that kind of was the problem that I experienced in my shop when I was doing software and doing my unit testing. And I was the only one doing unit testing, actually, on my project. And I caught a lot of flack from the other developers. None of us were developers. We all started off as scientists, and you became sort of developer by default, and you were the only one who could make an instrument talk to our systems. It was always a huge fight, and I was like, guys, this really makes it easier, makes it better. Let's all do this. No, you spend more time writing the test than you do writing the code. It's a waste of time. I was like, okay, well, I'm just going to keep doing what I'm doing, and you guys all get laid off before me, which they did. Sorry.
That's evil.
Yeah, I know. I'm evil.
This week, I'd like to pick an awesome cell phone hack from Dr. Volt, reusing an old Android phone for GPIO with external USB devices. This one's really fun. It takes an FTDI chip, which we usually think of as being a USB to serial converter chip, but some versions of it, the FTDI 232R, in fact, has a few GPIO lines on them. This one has 4, and he's using them to provide 4 pins output from an Android cell phone. I thought that was a really fun take on this. I've always wondered why it is that we don't use old cell phones in our projects, because they just have so many parts in them, from a powerful processor to a full accelerometer, gyro, magnetometer setup to a good camera, good audio out. I mean, there's a lot to love for reusing in a project in a cell phone. The problem is always how to interface it with the real world. This is a cool solution, I think, because it's deadly simple. It's wired. It gives you 4 GPIOs that you can use, and they integrate super well with the Android SDK, which I think has always been what stopped me from using cell phones in my projects is that the programming on the Android side of it is the hard part. And indeed, in this video, he spends quite a while going through the Android standard SDK to make an app on the phone that then you can press to make the 4 LEDs on the breadboard that are stand-ins for whatever other devices you want light up. But that said, this is a great walkthrough of how you could do so if you wanted. The phone in question was pretty old and may not have the USB on the go, which lets you inject power and charge the cell phone up while using it with your device. But the phone is also old enough that it has a removable battery. So he just pulls the battery out, sticks in a piece of perf board that's basically battery shaped, and powers the phone that way. I think that's absolutely lovely and a very simple solution for this. So that was super fun.
Who among us does not have a drawer full of old cell phones and tablets that would be able to be put to use with something like this? It's always tempting when I look there, and I think about doing a magic mirror kind of project or something like that. I really should put those things to work one of these days. And this maybe makes it a little easier because now you've got a way to get some GPIO and you don't have to go with anything weird like have a Bluetooth connection to some board that can do the I/O for you. No, why do that when you've got a USB? So it's pretty cool. I like the approach here.
Yeah, and if you read through the comments, I think that's kind of the consensus is that these days the wireless is the lowest common denominator, and maybe actually doing it this way is one step too hard. Commenter Retep P points this out. You've got an ESP32, it's got Wi-Fi, the phone has Wi-Fi. If you're already used to coding for the ESP32, it might even be the path of least software resistance to just whip up a quick HTML page on the ESP32, host it there, use the browser in your phone to connect to it and control it. I think there are reasons you probably don't want to do that, and some of them are probably the latency between the phone and the device. If there's lots of complicated processing using all of the different sensors, that might be a problem. On the other hand, pushing all of the fast real-time stuff off to the ESP32 is probably a win as well. So I definitely understand both sides of this. Why, if you really just want some simple GPIOs, maybe doing the FT232 trick is the way to go. If you have more complicated demands, I think it's probably worth looking into maybe using Wi-Fi or, as Dan suggested against, Bluetooth as the middleman and doing some of the heavy lifting on the device in question.
Okay, last up for me, portable solder paste station prevents smears with suction. Now this is what we were just talking about before when we were talking about that Quadruped project. This little solder station makes an appearance in there. The idea here is to make your solder stenciling neater and easier. This one is version 2 that Max Scheffler has built. This is a portable version of it. His previous version is basically the same mechanically and in the whole concept of vertically lifting the stencil up off of the PCB after the paste has been applied. And that's accomplished through a sort of a parallel lift mechanism. The upper platform upon which the stencil rests is sort of is spring-loaded. So when the vacuum is turned on and is pulling air through the perforations, that moves this platform down that's holding the stencil, that moves down onto the platform that's holding the PCB underneath it. The stencil and the PCB are quote unquote glued together by atmospheric pressure. So you're good. Your stencil's not going to move. Your PCB's not going to move. You can smear your solder paste on there. Make sure everything's good, and then turn the vacuum off as soon as the spring preload overcomes the remaining air pressure. The stencil pops up directly away from the PC board. No smearing, no lifting on the edges of the solder pads. Real nice, real simple. But the previous version that Max made was powered by a shop vac. That seems like massive overkill for the job. It'd have a shop vac roaring away on your benchtop connected to this stencil holder by a hose Not everybody's got the room for a shop vac. Not everybody has a shop vac. It's loud. There's a lot of disadvantages. So he undertook an upgrade of the concept and wanted to make it an all-in-one unit where it had a vacuum fan built into it. So as you do, you go on the usual 3D design suspects sites online, and you find the design for an impeller that you can 3D print. Max did that and gave it a shot with basically just sort of a puny old regular everyday motor, and got exactly the kind of results you'd expect. Stencil didn't move, the top didn't suck down, there just was not enough oomph. So he rejiggered the whole thing and came up with a brushless DC motor and a 3D printed impeller, kind of ditched the whole toroidal enclosure that he had used for the first impeller and went with a more open airflow design that basically uses the entire lower part of the station as a kind of a plenum, and has lots and lots of airspace to get rid of air. That worked a whole lot better. Even if the controls for controlling the speed and the speed of the brushless motor, all that, you needed a motor controller and a microcontroller to talk to the motor controller and all that stuff. So kind of overcomplicates things in some ways, but if you got it and you know how to use it, put it to work. And I think that's what he did here. The video that's included with the article goes into some detail about the construction and the dead ends that he went down before he got to the final form of this. But basically, what you see is what you get. You put the PCB onto the top plate, and that is custom made to fit the PCB you're going to be working with. So you would print a new one for different size PCBs or different shape PCBs, and then you put the stencil on top and turn on the switch, turn up the knob, and it just sucks right down. Put your paste on. All done. Very neat, very slick, and good looking project too. Really liked it.
All right, for my quick hacks, I can't believe you didn't pick this one. Ham radio rookie random wire antenna uses no wire. This is a really neat antenna made out of a 7-meter long telescoping carbon fiber collapsing fishing pole. I actually have one of these in the basement. It's funny, Al was like, where do you even get these? I use mine for getting lost RC airplanes out of trees. That's not the point. These poles, despite being made out of carbon fiber, are not very conductive. So the trick to turning it into an antenna is Ham Radio Rookie takes some conductive Faraday tape and puts stripes on each of the individual sections. And when you pull them out so that they telescope into each other, it somehow connects between the segments. And he's thinking that it's probably capacitive coupling between the two, because there's like strip of tape, probably non-conductive epoxy carbon fiber, and then strip of tape. And I think that might be true. I don't think he's done any particular investigation into this and tuning, and maybe that'll come in a later video. But it's a really neat idea to get a very long wire up and firmly mounted in a quick amount of time. So we'll see. If this can end up being tunable as well, I think it's going to be an even more interesting project. Wicker Waka Pico ROM, a DIP32 8-bit ROM emulator. This is a Raspberry Pi Pico doing its thing. He's flashed it with some software that makes it emulate an old ROM. He's using this ROM in an old arcade board and wants to test putting different software on the thing. The Pi Pico is easy to connect to by USB, so he can just write a new image to it and then boom, he's off to the races. What makes this work, of course, is the programmable input-outputs on the Pico, which let it respond quickly enough to pretend to be an EEPROM without losing a beat. And last up is kind of an art piece, and unfortunately a little bit short on details. Clap Clock, a split flap clock, flutters its way to displaying time without numbers. This is the coolest split flap display I've seen in a long time. It's basically a circle, and the split flap clock is just drawing hands on this otherwise circular face. But if you watch the video, the split flaps are a side-to-side split rather than an up-down one. They're kind of like flip dots in that sense, more than they are like a split flap display. It's not going through all the letters of the alphabet. It's only got two states, black and white. But have a look at it, and I'd be interested to see if anyone knows what's going on with these individual elements or is interested in recreating them.
Okay, first up for me for quick picks, word of the day calendar is a great use of e-paper. This is from Daedal Tech. I used to love word of day calendars, which would just have 365 pieces of paper and you'd peel them off every day and it would have some cartoon or something like that. I remember I gave one to my wife. There's Latin words every day so she could relive her high school Latin class glory days. This one is a little bit more conservative with the waste of paper. This one uses a wave-share e-paper display. Really quite small. The clever thing about this is the use of a wall plate, for an electrical switch, and the space that the switch would occupy, the Decora type switch, is occupied by the e-paper display. And then it goes out to the site and grabs a French word for the day. So very nice looking project and super tiny and kind of a good idea on a lot of levels. Next up, use Pico Glitcher for voltage glitching attacks. I've been much into glitching attacks lately, just because it's kind of cool. The idea that you can force an error state into an MCU by bathing it in RF energy or giving it a little kick on the power supply. Pico Glitcher is basically falling into that latter category. This is Matthias Kessenheimer's effort at learning how to reverse engineer through glitching. It uses some level shifters to connect different targets to different voltages and try to inject an error at different points of code execution cycles and inject errors that will let you figure out what's going on in the system. Pretty clever and seems nicely set up for kind of universal use. And last, Clever Circuit makes exercise slightly less boring. This is by Joel. I wrote this up the other day because I really liked the Forrest Mims shout out that Joel used here, because he turned to the still useful after all these years engineer's notebook from 1979 to pull out a bounceless switch circuit that would make his lap counter for his exercise routine, which is just going up and down the stairs 108 times. He often lose count of the number of trips he's taken, so he built this automatic optical beam brake sensor that uses this cool little bounceless switch circuit to actually do the counting.
All right, that brings us to the Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I installed Gentoo So You Don't Have To by Brian Cockfield. And first off, kudos to that title. The have to is hilarious. But second, I used to be an old Linux zealot and basically Linux tinkerer. And Gentoo has always been one of those like holy grail operating systems. And Brian has the same experience. Basically, it is a distribution where everything is self-compiled by you. In principle / on paper, and maybe in the past, this meant that you could customize everything to your exact needs and could hopefully get some kind of speed or efficiency or size gains out of it. And while that is Brian's motivation here, he actually finds out he doesn't get any of that out of it. And I think part of the reason is that the kernel's not this big mess of a whole bunch of modules all put together anymore, but everything's kind of modular and parts plug in, parts plug out. You are not going to get much out of optimizing the kernel for your machine, I think, these days. So he doesn't get much speed out of it, but what he does get is a tremendous learning experience. And I think that's the real point of Gentoo Linux, or even some of the other, kind of bare bonesier Linux distributions. He throws a little bit of loving shade at Arch Linux here. Arch is a little bit do-it-yourself on the install phase, and I absolutely agree with that. And if I were to do my systems again, I'd still do Arch, but I would hate having to do the setup phase because it does take a while, and you do have to think harder while you're configuring it than you would possibly like to. Gentoo is like that times 10. And so the other half the reason he wants to do this is that so he can toss shade at Arch people who use precompiled binaries. And I appreciate that too. But I think the point of Gentoo, and actually the point of Arch too, is that you learn so much when you have to make all of these choices yourself that it's actually kind of interesting. Is it for you if you just want to set up an operating system and get it going and get to work? No, absolutely not. These are kind of Linux hobby operating systems. This is the one you want to set up if you want to learn about how the operating system works. And I think that goes double for Gentoo. The good news is, Brian mentions this also gets picked up in the comments. The good news about Gentoo in particular, but also Arch, is they have phenomenal documentation. And so if the point of this operating system really is for you to learn everything about what it takes to get a Linux system up and running, it's absolutely fantastic because the documentation is there to take you through every step of the way. Now, again, is this easy? Is this quick? No, it's not at all. Is it an in-depth tour into what makes a Linux system tick? Yes, it absolutely, absolutely is. I think I'll throw the link to the Gentoo handbook in here. I don't even use Gentoo, and I look at the Gentoo handbook sometimes when I have problems because their documentation is just that good. You know, it's a resource for all Linuxes, not just for Gentoo. He does also point out that there are a bunch of ways to kind of speed this whole thing up if sitting around waiting for compilations isn't your style. There are a bunch of binary packages that you can work at around the corners to cherry pick a few of them to speed things up. In particular, browsers take forever to compile. At the end of the day, Gentoo isn't so bad once you've got it installed because they do have a really nice package manager, the emerge system. When software gets updated, it's not like you have to go through this long whole suffering thing again. You just fetch it down, recompile it again. You don't have to like revisit your whole system configuration. It's actually as easy as just getting it and running it. Brian's report on Gentoo here is that installing it took a lot because he had to learn a whole bunch of things and because you have to spend all that time compiling. But once it's up and running, it's actually a fairly easy system to keep running and keep maintaining and keep current with modern builds. So in that sense, I think it's not so bad. You're signing up for a one-time vacation deep inside the Linux kernel, not a lifetime of hacking.
I kind of no longer fit into the Linux power user sort of crowd. If this is the measure of, you want to compile your own operating system, then yeah, I guess I don't. I just kind of need to get stuff done. Then again, I've got Ubuntu on my laptop here, and everything I do, is my daily driver. Not that means anything past that's the operating system that I chose because mostly because I'm cheap and I don't want to pay for Windows. I do appreciate the exploratory potentials of something like Gentoo, so you can, find an old machine in a closet someplace and just throw it on there and see what you can do, see how, an operating system actually works. I do appreciate that stuff. I just unfortunately don't have time for that anymore, and I just need a machine that works. My pick this week for Can't Miss is Capturing Light in a Vacuum, the Magic of Tube Video Cameras. Jenny List's ode to the video tubes of old is kind of hits home for me because I did a lot of video work in high school. It will come to the surprise of no one that was me on the AV crew, and I remember vividly the getting sent to do a high school football game with brand new video camera, and it was probably a Panasonic, and I don't remember specifically, but we had this VHS deck for recording the signal, and we had this camera. And we were up in the booth, and the guy who, the faculty member who was actually in charge of the whole thing was very adamant about not pointing the camera at the lights. He had the big Friday night lights kind of shining down onto the stadium. And he was like, you put that camera toward those lights and it'll ruin the brand new camera. And, it was like $500 camera back in the 80s or something like that. So that was a big deal. And there was one time kind of grazed the edge of the lights, and he was smacking me around for that. That I just destroyed the camera. I didn't, but I understand the caution, and now after reading Jenny's article, you can kind of see why that would happen. Pretty much all the cameras we have now are using some sort of solid state image sensor, and they're smaller, they're better, they're faster. And in every way, they're better than the old tubes, Vidicons, Nuvicons, all the other different con type tubes that used to populate these cameras. After high school, I started working for a company that was doing video production, and they were using broadcast grade equipment, and those cameras had 3 tubes in them. Jenny does mention that somewhat in the article, that that broadcast cameras always had 3 tubes and a beam splitter sort of arrangement, so you'd get a red, green, and blue signal. The sort of the home grade and the prosumer grade cameras, they've got one tube because tubes are very expensive. And then they would do color by, kind of a version of color filters or over the tube. There were interesting pieces of equipment. There was a lot of stuff jammed into those professional sort of ENG grade cameras that we used to use. The article that Jenny wrote here is based on the simpler cameras that she has in her possession. She's got a couple of RCA or security cameras that came out of the mid 80s or so. She kind of does a little teardown of what's going on inside there. The whole concept of the Vidicon or the camera tube in general, they went by different names from different manufacturers and slightly different technologies. But the basic idea, she explains, is very simple. It's a screen at the front of the tube that is going to get exposed to the light that's coming through a lens or some other optical arrangement, and that illuminates the material that's on the front of the camera, which is photoemissive. So if it's being illuminated, it's going to give off more electrons, and if it's dark, it's going to give off less electrons, and then an electron beam rasters over that scene, and then you can get a current that is proportional to the amount of illumination that's in a particular place on that scene, and then that signal can then turn into a voltage, and the rest is sync and history and all that stuff. It was an interesting way to do the job. That's what we had. That's how TV worked. And just kind of going through the differences between the tube technology and the simplicity of solid state cameras that we have now is interesting. One of the things that occurred to me when I was reading this article, and I probably said this before, but TV was, and everybody was sitting down watching, and you're having this shared experience, and then you would talk about it the next day. Oh, did you see what they did? Blah, blah, blah. And you'd, talk about your favorite scenes from whatever show. So you had this kind of shared experience, but it was also shared in experience in another way, in a level that you probably weren't cognizant of at the time. The electron beam in everybody's TV was pointing at the exact same place at the exact same time. Because that's how TV had to work. The frame couldn't be a couple of lines behind on your neighbor's TV. They all had to be in the same place at the same time. Everybody was having a shared experience at a higher level, but at a lower level too. Everybody was watching the electron beam at the exact same place, the exact same time. I just thought that was kind of cool, and the Vidicon sort of turned that around, so it's basically the same technology as a cathode ray tube. It's just, instead of generating light for people to see, it's reading the light that's falling on the screen. So kind of interesting that, how much technology has changed, and a little bit jealous that Jenny's got all these fun little tidbits lying around that she can take apart and whip up an article on. It's kind of cool. I wish I had a deeper bin of stuff like that myself, because I had come across a lot of this cool stuff in my time in electronics, and most of it's sitting in a landfill someplace now. It's kind of cool that she kept hold of some of this stuff.
This was one of those today I learned articles for me. I had no idea how these old video tubes worked. And you explained it really well, so I'm not going to redo that. But what's striking is how much it's just a cathode ray tube run in kind of a different mode, right? Instead of aiming the beam around and lighting up different glowy sections, you're aiming the beam around and reading how much current it takes, because you've got a photosensitive material on the outside. And that's just crazy. And it makes the whole system make a lot more sense, because everything really is all kind of in sync with itself. And it's the same thing on the one side, on the recording side, as on the playback side almost. It's just, here you're measuring the voltage and turning that into the signal, and here you're using that to deflect the beam around. That's really cool. I don't know. Maybe it's just me. Maybe I just learned something new today, but this is a great one. Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And to follow along with the links, head on over to the show notes, hackaday.com/podcast. And until next week,
keep on hacking.
There we are again.
Well, we're just going to have to deal with it.
I can't use any of this in the show. I did what I thought I didn't do. I just did it wrong. Burp, excuse me. I think I'll delete all that. I think that's the perfect ending. I'm done.